Reflection and refraction. First I'll look at reflection of light from a plane mirror. So we have a ray of light coming towards a plane mirror and reflecting something like this. We call this the incident ray. This is the reflected ray, and if we draw a line at 90 degrees to the mirror, which we call the normal, we then call this angle between the normal and the incident ray the angle of incidence, which I'll label I. This angle then is the angle of reflection, and we call that R. We always find that the angle of incidence equals the angle of reflection, or I is equal to R. This is known as the law of reflection. Now to look at refraction of light as it travels from air into glass. So here we have a ray of light entering a piece of glass, and you'll see as it enters the glass it bends or refracts at this point. We can draw a normal at 90 degrees to the surface and call this angle theta 1 and this angle theta 2. You'll see that the ray of light has been bent or refracted towards the normal. This refraction is caused by a change of speed, a slowing down as the light travels from air into glass. We can understand why this happens if we consider a wheelchair moving from concrete onto grass and then back onto concrete. When the wheelchair has travelled to this point, the wheel nearest to us will be on the grass and will slow down, causing the wheelchair to change direction slightly. At this point, the wheel nearest us will reach the concrete first, speed up, causing the wheelchair to go back to its original direction. Something like this. The amount of refraction is given by what's called the refractive index. The refractive index of a substance S is given by the speed of light in a vacuum divided by the speed of light in substance S. Or in symbols we can write that the refractive index N is equal to c, the speed of light in a vacuum, over c sub S, the speed of light in substance S. For a vacuum, N is equal to 1, and we assume that N is 1 for air as well. Here we have our refraction diagram again with the angle of incidence theta 1 and the angle of refraction theta 2. If the light is going from substance of refractive index N1 into a substance of refractive index N2, we find that N1 sine theta 1 is equal to N2 sine theta 2. This is known as Snell's law. However, if the light is travelling from air into a substance of refractive index N, N1 sine theta 1 equals N2 sine theta 2, as before, Snell's law, but N1 is equal to 1. So we can write that sine theta 1 is equal to N sine theta 2. And so N, the refractive index of the substance, is equal to sine theta 1 over sine theta 2. In reality, when light meets an interface, some light is reflected, like this ray here, and some is refracted, like this one.